So good afternoon, folks. This time around, I'm bringing in two distributions, binomial and geometric. Well, these normally follow after discrete random variables. So let's have a look at what we have here. I think we're going to start with geometric. Let's see. Um, what we want to look into is the approach that we use when computing geometric distribution. Probability that x takes a value k. It means we should have failed k minus 1 times, then we succeed on the k trial. We also want to calculate chance that our variable k is less than a given value taken by x, or k can be greater than or equal to a given value of x. So if we want to compute the mean, in their formulas, the mean of a geometric distribution is given by 1 over p, where p is chance of the success. And if we want variance, I think variance is written in a complex way. 1 minus p is the same as q over p squared. So we need to have this in our minds as we solve geometric problems. A bit of examples there, but we are going straight into questions. Want to check if we can do it together and draw solutions. Let's have a look. There are about 10 classwork questions that we want to check if we can attempt and see the results. Right. First problem we have there is a geometric distribution, and we're interested in probability that x is 4. So what it means is when x is 4, this is just the same as q will be 3 times, then we have p. But what's our q? Q is 0.7 because this is our p. Then multiplied by our p, which is 0.3. But remember, q is to the power 3, so it will be like that. Let's have a look at what we have on our calculator. 0.7 to the power 3 multiplied by, well, let's start again, 0.7 to the power 3. Then I drop down, multiplied by 0.3. Our result is 1029 over 10,000. So this is 1029 over 10,000. So moving to the next problem, let me try and create a bit of space there. Here we are being asked to find probability that x is actually 1 on a geometric distribution, which is that. So if x is 1, looks like there's nothing to compute there. When x is 1, it means you're actually succeeding on the first trial itself. So chance that x is 1 is actually 0.2, because here we'll be having the p. Let's have a look. Next is another geometric problem where we are interested in C, because we have P, the success, but mind you, P and Q, they are complementary. In other words, if we add them, they give us a 1. So I've got 0.5, it looks like it's just the same. I want chance that uh, x is bigger than 2. So when x is bigger than 2, it means it can be 3, it can be 4, moving on like that. But in essence, if I want that this problem or this scenario, it means is the same as I failed twice. So this is just the same as q actually squared. And when I say q squared, it's just 0.5 squared, which will give us, I'm sure it's 0.25. Then next, we have got our p there. Let me try and clear space first to say, if I'm interested in my x being less than or equal to 4, it means what I don't want is to fail 4 times. So this is 1 minus failing 4 times. When I do my substitution, it's 1 minus. For this scenario, this is my p. So obviously we said p and q, they give us 1. So what it implies is q is actually 0.9. So this will be 0.9 to the power 4. So how do I work it around? I'll bring my calculator and say 0.9 to the power 4. I check what I get, and that's the result. So I'm going to say 1 minus alpha answer, and it gives me 3439 over 10,000. So it's 34, 39 all over 10,000. Now I'm on the fifth problem. A player has 70% chance of uh, of um, of scoring, then find probability that x is actually 3. So if x is 3, then it means we have failed 2 times. So that's q squared p. And when I bring in my q is going to be 0.3. And just to be to the power 2 multiplied by 0.7, the chance of success. And I'll need my calculator here to say 0.3. If I square it, then I multiply it by 0.7. And the result is 63 over 1,000. So that's 63 over 1,000. Then moving on, I've got another problem there where I'm interested in the mean of a geometric pattern. So I know that mean or the expected value of x is 1 over p. And this is my p. So this is actually 1 over 0.4, which I believe will give me 2.25. That's 1 divided by 0.4. And that's 2.5. So 2.5. Moving to number 7. I'm interested in variance there. So if I need variance, I think is the formula which is important to get variance of x. Um, so we are saying variance of x, we say it is q over p squared. And this is my p, implying q will be 0.4. So I'll be having 0.4 in the numerator over 0.6 squared. Let's try and check what we'll get from our calculation. I'll put my equal sign there, then I have 0.4. Let me try as a fraction. I have 0.6 squared. Then I try and check what the calculator will say. It's 1 and a 9. So my result is 1 and a 9. Sorry, 1 and a 9, not 1 and q. Right. Then next we have another problem there. A die rolls a 6 with probability 0.25. Now, this is our P. So we are interested in probability that x is bigger than 5. So chance that x is bigger than 5 is as good as failing 5 times. So that's q to the power 5. And when I check there, this is my P, implying my Q is going to be 0.75. So this is 0.75 all to the power 5, which will give us, when we calculate 0.75 to the power 5 and check what we get there, 243 over 1024, 243 over 1024. Then these are open questions, which I have bonus for you to think about. I think that's it basically from the introduction to geometric distribution. Thank you.